Welcome to this lesson on scientific notation. Scientific notation is a specific way that we write numbers that are especially large or especially small. So when we think of numbers that are especially small, maybe we're thinking of the diameter of a strand of hair. Or maybe we are looking at something at an atomic level. Those are things that are really, really small numbers. Big numbers could be things like something in outer space, or the diameter of a planet, or the height of a building, or the population of a country. But when we have numbers that have a whole lot of zeros in them, it can take a long time to write those numbers with all of those zeros. So scientific notation gives us a way to write the number, and instead of writing all of those zeros, we write times 10 with an exponent. Let me show you what I mean. This is our format, and the format is going to be the same for any scientific notation problem. The first number that we see, this is what we call the factor. The factor is going to be a number in the ones place. So that will be a number that is 1 to 9. And then there might be some decimals afterwards if we need to. Then we will have a multiplication symbol, the number 10, and an exponent that's attached to the 10. And that exponent can be a positive or a negative number. If we go back and look at these different kinds of numbers, our really large numbers have positive exponents. Our really small numbers have negative exponents. So they can be either one, but those factors are all in the ones place, and then that times 10 across the board for everything, and then our exponent. So that's our format that we use. It's important to know how to go in and out of what we think of as a standard format, sometimes they call it expanded form, into a scientific notation format. So let's start with going from standard into scientific, and then we'll go scientific into standard. So if we look at a standard number like 213 million, well, first we need to put a decimal right after the first number. So we're going to put a decimal right there. And then we're going to count how many spaces from that decimal to the end of the number. We're going to go 1, 2, 3, 4, 5, 6, 7, 8. And that amount of spaces is what gives us our exponent. So we put the first number, the decimal, and any other non-zeros after it. Times 10 is always going to be a part of the problem. And then those spaces that we counted becomes our exponent. Now, if we're starting with something that already has a decimal and nothing in the one, so a really tiny number, then we are still going to find our first number that's not a zero and put the decimal right behind it. But now we're going to count from the new decimal over to the old decimal, and we went 1, 2, 3 spaces. So that gives us our negative 3. So if we have a really tiny number and we need to count to the old decimal, then we do a negative exponent to show that. If we're going from scientific into standard, we start with our factor and we take out the decimal. And then we take our exponent, and that tells us where the decimal was. We need to go 4 spaces. So 1, 2, 3, 4. And we fill in zeros in those empty spots. And that's how we get to our 56,000. And again, when we've got negative exponents, we're going to write our number and imagine where that decimal was. And we're going to go 5 spaces to where a new decimal would be. 1, 1, 2, 3, 4, 5. And draw that new decimal. And we're going to put in 1, 2, 3, 4 zeros to fill in the space. So it's all a matter of putting the number down, figuring out if you're creating a big number with a positive exponent or a small number with a negative exponent, and using that number to be your spaces. Over here on the right-hand side, I've listed out those different steps and some different problems that are written, or numbers that are written in both standard notation or decimal notation and scientific notation, so you can compare the two. But go ahead and pause this video and try these problems. Try this 1, 2, and 3, 11, 12, and 13, and then the 21, 22, 23, 26, 27, and 28. Try going back and forth and see how you do. Remember, you've got your answers on the back of the page, so you can always check your work after you're done trying it. But pause the video now and go ahead and try those by hand. All right, now that you've had a chance to work on those, go ahead and check them on the back or up here. I do want to let you know there is a typo on your answers. This number 3, they accidentally wrote 2.5 instead of 7.5. So if you saw that on the back and you were confused, good reason. That answer on the back has the wrong number in the factor. It should be a 7.5. Hopefully you're feeling a little bit more familiar with how this process works. Remember, if you're feeling utterly lost, you can look and see if the sub is not busy with someone else, and you can raise your hand and ask her to come help you too. But hopefully between me talking and these instructions on the right and the practice problems, you're starting to get an idea. It's important that we know how to do it. But I also want you to know the calculator can help us do it as well. And so I'm going to walk you through a couple of different concepts with the calculator, and then I'm going to show you a portion of our calculator video on our class website. And that portion specifically shows working on the calculator, and you can do it with me through that video. So let's just talk about a few things first. When we look at our calculator, there is a specific scientific notation key, and it already has the multiplication and the 10 as part of the problem. So when you are writing a number in scientific notation in your calculator, you will not use the multiplication key, and you will not need to write the number 10. So those are already a part of using that scientific notation key. The other thing is, when you're trying to decide what you need to do with your calculator, you need to look at the answers. If your answers are still in standard notation, that expanded form that we were working with, then keep your calculator in your regular normal mode and just use that scientific notation key. However, if your answers are written in scientific notation, so your answers in the problems look like that, we need to change the mode in our calculator. So to change the mode, you hit that mode key right there. It's up in the very top row, middle button, and it's going to show you these 4 lines of text. To navigate those lines of text, you're going to use your wheel. So when it first shows you, degree is going to be blinking, and you want to go down on the wheel to this second line. And norm typically will be the one that is highlighted. We want psi, so then you're going to use the right part of the wheel to move over to psi, and it's going to start blinking. To keep psi chosen, you press enter. And once you press enter, your screen then on your calculator should look like this, where it's got degrees, psi, float, and math print. And when you're ready to get back to your number screen to put problems in, you hit the clear button and it will save your data but take you back to the number screen. So go ahead and try that a couple of times, switching between normal mode and scientific mode. And remember, it's all about what format your answers are in. If it's in a decimal or an expanded form, then we want to be in norm. If it's in scientific notation, we want to be in psi. So go ahead and pause this video, play with it a little bit, and then I'll show you my calculator video so you can actually see my fingers moving on a calculator and see what it looks like. We can also use this calculator for scientific notation. So when we're talking about scientific notation, it's something that looks like this, where it has a base number times 10 with an exponent to it. Scientific notation is for numbers that are incredibly large, like distances in space or populations of countries, or for numbers that are incredibly small, things that we can only see with microscopes. And doing that times 10 to the something helps us not have to write out all the zeros that are there. And so your calculator can do it. But if you're going to put something like this into your calculator, well, let's break it up. Let's just do that 3.6 times 10 to the 8th first. So on our calculators, we're going to do 3.6, and then we're going to use this button, times 10 to the 8, and then press enter. So that's what it looks like in what we call standard notation. So scientific notation has that times 10 to the something. Standard notation looks like this. There is nothing wrong with writing this down and then doing the second part, that 2.4 times 10 to the third, and writing it down and then doing division, but it's really slow. And there's a much faster way to do it. And so you can put it in your calculator. You can do parentheses to tell the calculator that this whole scientific notation number is one specific thing. Then we want to get out of the exponent and close our parentheses. Then we're going to do divided by, because remember, every fraction is just a division problem at heart. Then we're going to start a new parentheses, 2.4 times 10 to the third. Then we're going to get out of the exponent and close our parentheses. And so there it is as a standard number. So if your answers are all standard notation, you're done. You just have to make sure you put parentheses around each part of the scientific notation pieces. But if your answers are in scientific notation, your calculator can do something really cool. So we're going to go back into mode. And instead of being in normal, we're going to go over to psi. That's scientific notation. So we're going to go down one and to the right one and press enter. And now look, norm's not highlighted at all. It's just psi. So we're going to press clear, and then we're going to do it again. Same exact format. Parentheses, 3.6, x10 to the nth, 8, right arrow to get out of the exponent, close the parentheses. Divided by, start the parentheses, 2.4, x10 to the, then we're going to do the 3. Then we're going to get out of the exponent, close the parentheses, and press enter. And there it is. It's the same number, but this is what it looks like in scientific notation. And this is what it looks like in standard notation. So depending on what your answers are on the test, you may just want to stay in normal if your answer looks like that. But if your answer is still in scientific notation, then click that mode button and go over to scientific notation. But this is important. Once you're done doing that problem, go back into mode, back down to normal, enter, clear. Because otherwise, all the rest of your calculations you're going to be trying to make are still going to be in scientific notation, and you don't want that. Okay, now that you know how to do it on a calculator, go ahead and look at that whole page of problems. We've already done 1 through 3 and 11, 12, and 13, 21 through 23, and 26 through 28. Try the rest of them with the calculator. Just let your fingers get used to how it works with scientific notation. And remember, these first problems want your answer in scientific notation. So your calculator mode needs to be Sci. These want your answer in standard notation. So your calculator mode needs to be in Norm. Go ahead and pause the video, try some out. Okay, so now that you're familiar with how they work and what they look like, let's look at some kinds of problems that we might see scientific notation in. The first kind of thing that they might want you to do is actually to compare numbers in scientific notation. Which one is larger? Which one is smaller? So when we're comparing numbers, we need to actually look at two different parts. We need to look at both the factor and the exponent. And we're actually going to start with the exponent. If the exponent is larger, the number is larger. If the exponent is the same, then we move on to looking at the factors. If the factor is larger, the number is larger. So let's do a couple together. Looking at these two numbers, we need to examine the exponents first. And when we look at the exponents, the larger exponent tells us that that's the larger number. But in the second example, the exponents are the same. So then we look at the factors, and the one that is the larger factor is also the larger number. Go ahead and try some on your own. Press pause on the video, and even though you don't have these in your packet, you can just kind of look in your head and write down on a piece of paper which one you feel like is the larger in each one of the pairs. And after you've worked on it for a little bit, press play on the video again, and we'll go over it together. Okay, so for number 1, we're going to start by looking at the exponents, and that tells us this one is larger. We're going to look at the exponents for number 2, and that one is larger. We're going to look at the exponents, and they are the same exponent. So now we're going to examine the factors, and that tells us that that one is larger. Looking at the exponents, that one is larger. Looking at the exponents, they're the same, so we go to the factors, and that one is larger. Looking at the exponents, they're the same, so we go to the factors. And if you're ever trying to compare decimals, which one is larger and which one is smaller, it's okay to add zeros after the last number in the decimals. So 2.6 is the same thing as 2.60. And when we're trying to compare 2.60 and 2.09, that might be a little bit easier for your brain to see that that is the larger decimal. How'd you do? Sometimes these comparisons happen with story problems. If we look at these two story problems, 8 and 11, the question is actually the same question. Approximately how many times larger is the first than the second? Approximately how many times larger is the dust mite rather than the human hair? So that how many times larger or smaller is actually a division problem. And then when we're going to do a division problem with scientific notation, we need to use some parentheses on our calculator to make groups. So it's going to be the larger divided by the smaller. So in this one, they tell us the larger is the first company's orders. Well, we knew that anyway because that 7 in the exponent tells us that's the larger number. But because we want this 5 times 10 to the 7th to stay together as a scientific notation number, that's when we're going to use the parentheses on our calculator to create a group. So your parentheses are the keys that are right above the 8 and the 9. So the start parentheses is above the 8, the close parentheses is above the 9. So those are what we want there. Then we're going to do our division sign on our calculator. Then we're going to do parentheses again, 3 times 10 to the 6th, and then close the parentheses. Go ahead and do that and see what you get. Start parentheses 5, scientific notation key 7. See how your cursor's still tiny up next to the 7? Use the right part of the wheel. Hit that right part of the wheel and your cursor will go big. And then you can do your close parentheses, that button just above the 9. Then divided by, start parentheses 3, scientific notation key 6. Then you need to do the right part of the wheel to get out of the parentheses and hit that close parentheses right above the 9. And then press enter. And you should get 16.66666666, or we can say 16.6 repeating. And because they told us approximately, it's okay for us to round, and that gets us to 17. We're going to do the same exact process with number 11 because it's the same question. How many times larger? So we're going to have the dust mite first, which is 2 times 10 to the negative 4, and put it inside parentheses, divided by 6 times 10 to the negative 5. Put that in parentheses. Go ahead and put it in your calculator, 2, scientific notation key, negative 4. The negative symbol is down by the enter button. Use your right part of the wheel to get out of the parentheses and then press close parentheses above the 9. Divided by, start parentheses 6, scientific notation key, negative 5. Right part of the wheel to get out of the parentheses, close parentheses, enter. And you should get 3.33333333 repeating. And that would get us to a 3. Go ahead and try 9, 12, 10, and 13. The question is the same question every time. So we're going to do it just like we did those 2 on the earlier slide. So go ahead and press pause. Try out 9, 10, 12, and 13. So we've looked at how to go back and forth between standard and scientific notation. We've looked at how to compare scientific notation numbers to see which one is larger or which one is smaller. We've looked at using that comparison in story problems. This last page in your packet is a combination of all of that stuff together. So go ahead and try those questions now. Remember, your answers are on the back. Work your way through it. And then when you are done working on this page, you can take your break for 10 or 15 minutes, then come back and you'll be ready to do the advanced lesson with a different video.